Hello students, welcome back to my channel. Today I am going to discuss about class 12's the chapter continuity and differentiability and the topic some properties of continuous function and questions. So before we go to different types of questions, I just want to share with you some of the properties or theorems on continuous function. So here is some of the theorems which I have already written because of the shortage of time, otherwise the video will be very much long. That's why I have already written it. So the first theorem is every constant function is continuous. Constant function means there will be no variable in it. Like one example I can give that f of x equals to suppose k. K is a constant. So this function is a constant function and all constant functions always will be continuous. Theorem 2. The identity function is continuous. What is identity function? F of x equals to x. This is called identity function. X means the identity function's value, that is x, it is always continuous. Theorem 3. Every polynomial function is continuous. Polynomial function means f of x equals to like a0 plus a1x plus a2x square plus dot plus an x to the power n, like this. So this is the standard form of a polynomial of degree n. This type of all polynomial functions will be continuous always. So what are the polynomials? Difference means classifications. So polynomial can be linear polynomial, 1 degree term, quadratic polynomial, then cubic polynomial, biquadratic polynomial, and so on. All will be continuous. Theorem 4. Every rational function is continuous in its domain. Rational function means what? Rational function means p of x divided by q of x. Okay. Suppose f of x is equals to p of x divided by q of x, and this is a rational function. This will be always continuous where p of x and q of x both are polynomials, and q of x obviously will not have the value 0. Theorem 5. The composition of two continuous functions will be always continuous. Both the function must be continuous. Think about that. F and g. If these two functions are continuous functions, then g compose f will be continuous. Theorem 6. The exponential function is everywhere continuous. Exponential function means e to the power x, like this. Okay. Then theorem 7. The sine function is continuous everywhere. The cosine function is continuous everywhere. The tangent function is continuous in its domain. Means one of its domain, obviously one of the interval. Cosecant function is continuous in its domain. Secant function is continuous in its domain, and cotangent function is continuous in its domain. Then theorem 8. The logarithmic function is continuous everywhere. Theorem 9. The modulus function is continuous, means mod x. is continuous everywhere. Theorem 10. This will be 10. Sine of mod x is continuous. So these all can be proved, but the proofs I'm not doing here because the same thing I'll be telling what is there in the book. So you can go through the book and get the proofs of all this. Very easy proofs. Somewhere it is only 2-3 lines. So you can check it out. Now I have chosen a question for you. This is question number 1 I have marked. Discuss the continuity of the function f(x) at x equals to half, where f of x equals to half minus x, 0 less equals to x less than half. This is the condition for this value. Then 1 if x equals to half, then 3/2 minus x if half less than x less equals to 1. So I have written its solution also. Look at the solution. We have to check the continuity or discuss the continuity of the function at x equals to half. That means first we will check left hand side limit. That is limit extends to, this is LHL. This one is LHL. So limit extends to half minus f of x is equals to, look, before half, that means in the left hand side part of half, the value of fx is half of minus x. Half minus x. So limit extends to half, half minus x. That equals to half minus half equals to 0. Coming to right hand side limit, this is RHL. Limit extends to half plus f of x equals to, according to the given condition, for half plus f of x will take this value, that is 3/2 minus x. Now in place of x we can put half again. That means 3/2 minus half equals to 1. It is clearly visible that 0 and 1 are not equal. That means LHL not equals to RHL. So I have written in this form here, limit extends to half minus f of x not equals to limit extends to half plus f of x. So we can say f of x is not continuous at x equals to half. Now this is the question number 2 that I have chosen for you. It tells that determine the value of the constant m so that the function f(x), the first value for x less than 0 is m into x square minus 2x, and the second value is cos x if x greater than equal to 0 is continuous. That means the condition has been given as that f(x) is continuous. Then you have to find out the value of m. So what we will do? We will first do it for x less than 0. Now look, for x less than 0, f(x) is m into x square minus 2x. That is obviously continuous at each x less than 0. Why? Because for any value of m, this will be a polynomial. So polynomial, every polynomial is continuous. So f(x) will be continuous for x less than 0, and it is given also. Then for x greater than 0, f(x) equals to cos x is continuous at each x greater than 0. So what is left? The point x equals to 0 left. So let us take the point x equals to 0. Now the x equals to 0 points left hand side limit. Limit extends to 0 minus f of x equals to, limit extends to 0. For 0 minus, we will take this value, m into x square minus 2x. So we have written here m into x square minus 2x. Its value will be, for any value of m, you will be getting the value as 0 because m will be constant and it will be coming outside, and rest of the parts limiting value is 0. So ultimately m into 0 equals to 0 for all m, any m. Coming to its left hand side right hand side limit extends to 0 plus f of x equals to limit extends to 0, its cos x, and cos of 0 is equals to 1. Clearly you can see that left hand side limit and right hand side limit, they both are not equal. That means what we can say that the value of m does not exist for which fx is continuous. Because you can take any value of m, never it will be equal because always we will get 0 here and 1 here. So they will be always different. That's why we will tell that for fx being a continuous function, m does not exist. Now, another question I have chosen for you, that's question number 3. If fx equals to its 3-valued function, so 1 for x less equals to 3, ax plus b, where a and b's values are unknown, if 3 less than x less than 5, that means in the interval, open interval 3, 5, fx takes this value. Then for x greater equals to 5, means x's value either equal to or more than 5, then we will be getting fx equals to 7. Question is determine the values of a and b so that fx is continuous. That means fx is continuous at all points. Okay. So how we will be doing? Now look, the first thing that we will check for this one. Fx is continuous in this and this, means less than 3 and greater than 5. I am not taking the equal signs now. I am taking that if fx is for x less than 3 and for x greater than 5, fx takes the values 1 and 7, means fx is constant function there. So in both the cases, that means fx will be continuous for all x less than 3 and for all x greater than 5. Okay, because in these two cases we are getting constant value, so it will be continuous. Next, we are taking this open interval, what I was telling, 3, 5 open interval. Here also fx is continuous, it is given, and why it is continuous? Because it is a polynomial. So it's a continuous function. Then for x equals to 3, limit extends to 3 minus f of x equals to limit extends to 3, 1. The value 1 we will take. Why 1? Because 3 minus. So for left hand side part of 3, f takes the value 1. That's why it is 1. So constant function, so limiting value will be the same, that means 1. Similarly, for right hand side limit of 3, it will be ax plus b, fx will be ax plus b, and we are getting 3a plus b. Now, as f is continuous at x equals to 3, in the question it is told that fx is continuous, that means fx is continuous at all points. So it is continuous at x equals to 3 also. For continuity, these two must be same. 1 equals to 3a plus b, right? So 3a plus b equals to 1. I have named it number 1 equation. Similarly, for x equals to 5, we have done the calculations and we will be getting 5a plus b equals to 7. Okay, you can see the calculation once. So as it is continuous, that means we are getting 5a plus b equals to 7. Now we have got two equations, 3a plus b equals to 1, 5a plus b equals to 7. So we can solve it with elimination method, and I have done with elimination method. I got a equals to 3. Once I have got a equals to 3, I can put it in the first equation to get the value of b, and which will be minus 8. So what will be the answer line? The answer line will be the values of a and b are 3 and minus 8 respectively. So this is all about today's session, students. I hope you all have understood all the questions that I have discussed here. So there are similar types of questions in your book in the exercise, and the exercise number is 5.1. So there are many questions that you can now do by your own. So we will meet in the next video with any other topic. Till then, have a good day.